Hi guys, I hope you're ready to start week 12 on multiplying and dividing fractions. Now you should be getting a great idea of the behind the scenes of fractions and why students might be frustrated or confused. So let's try to make sense of multiplying and dividing fractions. This week we'll develop an algorithm for multiplying fractions and dividing fractions, and we'll investigate multiplying and dividing mixed numbers. As always, we'll be emphasizing certain math practices. This week is make sense of problems and persevere in solving them, and then MP6, attend to precision. Let's start with the problem. It's the brownie problem, so think about this problem and decide how you would solve it. And I would recommend drawing a picture. So you made a tray of brownies for your birthday party. After the party, 3/4 of the tray is left. You eat 1/3 of the leftovers. How much of the original tray of brownies did you eat? So pause the video here, make sense of this problem, and see what your solution might be to this problem. All right, here's how I did it with a drawing. First of all, when you're making sense of the problem, when it says you made a tray of brownies and after the party 3/4 of the tray is left, when I read that problem, the first thing I know is your brownies are not good, or maybe only you like your brownies, because I don't know what kind of party 3/4 of a tray of brownies is left, but that's just me. But when I made sense of this problem, I said, okay, I'm going to take my pan of brownies, which was a rectangular sheet of paper, and then I'm going to split it into 4 pieces, and I'm going to shade one piece since that's what was eaten at the party, or I could even fold that part of the paper behind. And so I marked what's left at the party, which was 3/4 of the tray. Then I noticed that I ate 1/3 of what was left. So what part of the original tray was that? That was 1/4 of the original tray. This is very similar to the chocolate bar problem. If you remember the Jill's chocolate bar and James's chocolate, how much of Jill's chocolate bar did James get? So anyway, you ate 1/3 of the leftovers, which is 1/4 of the original tray. If you look at this picture here, you might be able to tell that there's 1/2 of the tray left. So you ate 1/3 of what was left, which was 1/4 of the original tray. I hope that makes you think about what is the unit again and gets you really thinking about that idea. We can visually see that we ate 1/4 of the original tray of brownies, but what operation were you doing here? Were you doing addition, subtraction, multiplication, or division? Pause for a second, see if you can write the number sentence that you did. You might have thought maybe you're adding or subtracting. Subtracting is one I get a lot of times where people think, oh, they have 3/4, so they're going to subtract 1/3 from it. But it's actually multiplication. So you're taking 1/3 of the 3/4, which simplifies to 3/12, which simplifies to 1/4. So sometimes we can solve a math problem visually, and we might not even be able to put the numeric sentence with it because we just see the answer. So in this case, it was multiplication. And I rephrase that here. Sometimes word problems are difficult to decipher which operation makes sense, but do not underestimate the power of drawing pictures to model the mathematical situation. Remember MP4, Model with Mathematics? This is a great example of that. So fraction multiplication. Remember, you want to keep your model consistent for students' understanding. So when we were in whole numbers, the first factor was the number of groups or copies, and the second number was the size of the copy. The same should hold true when you're doing fraction multiplication. So here's a flashback example to whole number multiplication. So 4 times 3 equals 12 means 4 copies of 3 per copy. So that's 12 if we total all the copies. So here's an example. If we have fraction multiplication and we use that rectangle for the unit, we could represent 2/3, then we could draw a picture to visually show 6 copies of 2/3. And then we can answer those questions. How many copies of 1/3 are shaded? And then write a multiplication sentence illustrated by your picture. So let's take a look. If we use that rectangle as our unit, we could represent the fraction 2/3. Then we could draw 6 copies of 2/3. So how many thirds are shaded? There are 12 copies of 1/3 shaded. So 6 times 2/3 is 12 thirds, or 4 holes. And you could even think of putting this piece in this hole, this piece right here, this piece right here, and this last piece right here to make 4 holes. And you can see that. So here are some standards from 4th grade. So apply and extend previous understandings of multiplication to multiply a fraction by a whole number. That's a good place to start to make sure students can understand these visuals. And then the next one, understand a fraction a over b as a multiple of 1 over b. So for example, use a visual fraction to model 5 over 4 as the product of 5 times 1/4. Or we could think of 5 copies of 1/4, recording the conclusion by the equation 5 over 4 equals 5 times 1/4. That really works well with the copies of idea, so keep that in mind. And then the third standard that I wanted to bring up here is understand a multiple of a over b as a multiple of 1 over b, and use this understanding to multiply a fraction by a whole number. For example, use a visual model to express 3 times 2/5 as 6 times 1/5. Recognize this product as 6 over 5. Okay. In general, n times a over b equals n times a divided by b. So you can multiply the whole number times the numerator of the fraction. That's what they're trying to get across here. So here's one you can definitely do visually. Joe is very picky about pizza. He asks for pepperoni to be on half of the pizza and mushrooms on 3/4 of the pepperoni side. Did you read that very carefully? He wants pepperoni on half of the pizza and mushrooms on 3/4 of the pepperoni side. What portion of the entire pizza has both pepperoni and mushrooms? So pause the video here, try drawing a picture. Here's my picture. So I used a circle since a pizza is a circle, and I cut the pizza in half and I shaded it red. So half the pizza is red. But then I needed to cut that 1/2 into 4 pieces and shade 3 of them for the mushrooms. And so then, since I had half cut into 4 pieces, I could think of the entire pizza cut into 8 pieces. And I have 3 of them that have pepperoni and mushrooms. So it would be 3 out of 8. If I wanted to connect the multiplication sentence to it, I could write 3/4 times 1/2 equals 3/8. Now notice the 3/4 is first and the 1/2 is second, because I'm taking 3/4 of the 1/2, or 3/4 of the copy of 1/2. Students will also connect here, oh, I'm going to multiply numerators, multiply denominators. Let's look at this on a number line. This is something new for you, I'm guessing. So if we want to show 5 times 1/3 equals 5/3, we could do 5 copies of 1/3 in each copy. So we would get a total of 5/3. So the first thing I did was I drew a number line and I marked a 0 and 1 and 2. And then I split it into thirds and I labeled all those tick marks. Then I needed to take 5 copies of 1/3. So there's 1 copy, there's another copy, another copy, another copy, and another copy to land me at 5/3. So that's a visual way to show multiplication of fractions on a number line. Now you try fractions on a number line. This is 1/3 times 1/4 equals 1/12. You already know the answer because you know how to do the problem, but your students won't know. So when they do it, you're doing 1/3 copies of 1/4. So the first thing you'll want to do is show the 1/4 on your number line so you can see it. So we're thinking of 1/3 copies of 1/4. So first model the 1/4, then break the 1/4 into 3 pieces so you can take 1/3 of it. When you split that into those thirds, you could imagine splitting all of these sections into thirds up until 1 so you can tell what unit fraction that little piece is. And as you can see, it would be 1/12. Problem with an area model. So we could draw a rectangle and break it into thirds in one direction, and then break it into fourths in the other direction. And where that overlapping shading occurs, that would be our product. So in this case, you can see 1 square is shaded out of a total of 12. So our answer is 1/12. This is an interesting one that I'm not sure you're familiar with. Sometimes kids use mental math strategies and they have trouble describing them or even explaining if they're mathematically sound. So look at this one. If you were going to have to multiply 5/6 times 2/10, sometimes students will swap numerators and change the problem to 2/6 times 5/10. That allows them to simplify each fraction, 1/3 times 1/2, and they get 1/6. Sometimes that's easier computation for students to perform mentally. Does that always work? Does it make sense? Is it mathematically okay? You're going to be investigating that in one of your assignments. This is the problem that you're going to think through. So examine the diagrams below. What multiplications do they represent? And then notice how the numerators were swapped. And then there's some questions that follow. So you might want to think this through and try it before you get to that assignment. All right, multiplying mixed numbers. So Alicia made a very common mistake when multiplying mixed numbers. Her work is shown below. What did Alicia do wrong? Explain her misconceptions. So she had 3.5 times 2 1/4, and she got 6 1/8. What did Alicia do? Pause the video, think about it, and see how you would do this problem or correct your student. Well, what should she have done? So notice that she just multiplied the whole number part times the whole number part and the fraction times the fraction. That's not entirely wrong, it's just incomplete. So she does not have to change it to an improper fraction. She could, but she doesn't have to. And some of you, that would be your go-to way to solve these problems because that's how you were taught an algorithm. But let's think this through and make sense of it. She could use the distributive property and make sure she did all the multiplying. So 3.5 can really be thought of as 3 plus 1/2. And 2 1/4 can really be thought of as 2 plus 1/4. So think about the distributive property. And you can distribute the 3 to the 2. So that's 3 times 2. And then the 3 times the 1/4. And then you can distribute the 1/2 to the 2 and the 1/2 to the 1/4. If you do all those multiplications, you end up with 6 plus 3/4 plus 1 plus 1/8. And if you combine those, you will get 7 7/8. There's another way you can do it with an area model. Notice I put the whole number parts and then the fraction part. And then I just filled in the area model and added those products. That's another way to do these multiplying mixed number problems that you might be unfamiliar with. Try it on some of the homework problems. All right, you have an assignment on fraction multiplication with pattern blocks. Make sure you get that ready so you can fill in a couple of the answers so you know how to do that on your own. So we're going to use pattern blocks. The double hex is 1, which means the yellow hex is 1/2, a red trapezoid is 1/4, a blue rhombus 1/6, and a green triangle is 1/12. So 1/6 times 1/2, write in your copies of statement. That means 1/6 copies of 1/2. So when you draw your picture, you're going to model that second factor first. So you're going to model 1/2, which would be a yellow hexagon, and then you need to take 1/6 of it, which is to split it into 6 equal pieces and take one of those. And then write your multiplication sentence. Do the same thing with 3/4 times 1/3. That means 3/4 copies of 1/3. So model 1/3 with your pattern blocks, and then split it into 4 equal pieces and take 3 of them, and write your multiplication sentence. You might want to pull up the virtual manipulative or draw on paper. That might help you. The answers are on the next slide. All right. So remember, on the first one, you're going to model 1/2, split it into 6 pieces because we want 1/6. You take 1 piece, which is 1 green triangle, so my answer must be 1/12. The second one's a little bit trickier because we need to model 1/3, and that's not one of our pattern blocks, but we do have 1/6, and if we have 2 copies of 1/6, that simplifies to 1/3. So I use 2 blue rhombuses here, which divides nicely into 4 pieces, and I need 3 of those pieces. Notice that the 3 pieces that I've shaded are 3 green triangles, which is 3/12, or you could also see a red trapezoid, which is 1/4. So 3/4 times 1/3 is 3/12 or 1/4. The other side of that worksheet is rectangular multiplication with fractions. So you want to do 2/3 times 6, and then 2/3 times 1/2. So on the first problem, 2/3 copies of 6. So you're going to model 6 wholes and then take 2/3 of it. On the second one, you're going to model 1/2, and you're going to take 2/3 of it. So there's the solutions there. If you notice, on the first one, we modeled 6 wholes, and then we want to take 2/3. We could split them into thirds, which would put 2 rectangles in each third. And we want 2/3 of those, so we're going to take 4 rectangles. So our answer must be equal to 4. The second one is where we split the rectangle in one direction in half, and then we split it in the other direction into thirds, and then we take 2/3, which the overlapping part is 2 out of 6 or 1/3. So here's some examples from that Math is Power for You book that you can go over in the traditional method and then the picture method. Let's stop there and take a break because the next thing we're going to get into is division of fractions.